Hello and welcome to this video. In this video, we will study insertion sort, both the iterative version and the tail recursive version. So this is our driver program. We have the same array which we have used in previous examples, and we simply call insertion sort here. The header file has the prototype declaration of insertion sort, and this is the implementation file. So if you see, this simply prints the array in between the sorting, and this is another print statement in between the sorting. So first we run the program, then we will try to understand it. So we compile using the typical flags. We will need to include both the files. Okay, so it is compiled. Now we run this. So we have our sorted array over here, and all these are states in between. So we will look at this and try to understand the algorithm. So insertion sort takes two elements at any point of time and exchanges them in the array. So to start, we have received the array and the size. Now in this first for loop, we set j is equal to 1. Okay, and this loop will continue till j has hit the last element. So j is equal to 1 means 384. All right. Now we set y is equal to aj, that is y is 384 in the first iteration. Now I is equal to j minus 1, that is it will become 0. Okay. Now I should be greater than equal to 0 and y should be less than ai. So in this case, our y is 384 and a0, ai, that is a0 is 164. This condition is not satisfied. All right. So this will not even enter the loop because the condition is not satisfied here. So it will simply, what it will do is it will put ai plus 1 is equal to y. Now y is already ai plus 1 because j is 1 and I is 0. So it will have no effect. All right. And the same array will be printed. So if you look at this, and let's look at our driver program, we have 168, 384, and 705, 592, and so on. So in the first iteration, nothing will change. Okay. Similarly, in the second iteration, what will happen is, let's see. In the second iteration, j will become 2. So y will be a2, that is 705. Okay. And again, nothing will happen because this is already in order. All right. So these elements are in order. The first element which is not in order is 592. So we are looking at j is equal to 3. So when j becomes 3, y becomes a3, that is 592 in this loop. Now what will happen is I will become 2 because j is 3. So I will become 2. AI will hold 705 here and y will hold 592. Now I is greater than 0 obviously, and y is less than ai. Hang on, y is a3. Yeah, 592 is less than 705. So it will enter the loop and it will exchange this. It will replace ai plus 1 with the ai. So you see here, 592 is now replaced with 705. Okay, and the value of 592 is held in I here. Okay, it will then in the next iteration I will become 1. Now when I becomes 1, it will become 384. All right. So in this case, y is less than ai. Now what is y? 592. So it will not enter the loop. So it will only replace these two elements. Now, once this loop is terminated, ai plus 1 will be y. So what was our ai? Our ai was 592. So 592 will be replaced here. So this is that. Now first four elements are in order. Okay. So then 433 will get exchanged, and 592 will is here. You see AI plus 1 is equal to AI operation happening. This is also AI plus 1 is equal to AI happening, and 433 will reach here. Now these are in order. Okay, so it will start replacing 211. So you see it will reach a state over here. Now after this up to 890 is in order. Okay, so now it will take 777 and put it in its proper place. Once this happens, these are all in order. Okay, so it will take 339 and go on shifting the value until we reach the correct position. So it takes two elements at a time, compares them, puts them in the place, then takes two more elements, then two more elements, and puts them in proper place. That's what insertion sort algorithm is. Now let's look at the recursive version. So our driver program is more or less same, only the function name is different, and we have the header file. And in this case, what we do is, let's first compile and run this. Okay, what was the name? Our insertion sort main R. So this also compiles. Now, if you look into this, what happens is we are calling this repeatedly. So what will happen is A will be the same. Now it will reach n minus 1 and it will go in. It will see n is less than equal to 1 or not. And then it will go for n minus 2 and so on till n becomes 1. Once n becomes 1, it starts returning. So when it returns first and stack unwinding happens, n will be 2. So that means it is considering now two elements. N is 2, so y will be a1 and j will be 0. So what you are comparing will be a1 here with a0. So as long as j is greater than 0, it will compare the elements and fix them in the proper place. So at any moment, it will consider only two elements. Unlike the previous one, it will finally replace aj plus 1 with y, like in this. So this operation is same as this operation. And what we are doing over here is equivalent to this operation. And then this while loop is nothing but this. So that's how we implement recursive insertion sort. If you want to see that what is going on, then I'll show you. Let me copy the code. Okay, so we print the array over here. All right, and then we print the array over here, and finally we print the array over here. You will see that how it compares two elements at a time. So we have stdio. I will have to include. So let me include stdio. Okay, this is main R. Okay, we missed a statement here, this new line one. So let's copy that and put that here. So now we will have this. So you see, this is the recursive call happening of our insertion sort till here. Okay, rather till here. Once this happens, at this moment, n will be after this n will become 1. So it will start returning. So this array will be printed here. Now it has two elements which are in order, so it will be printed again. That is finally over here. Now then the stack winding will happen again, and we will get the third element in the array. Now this is also in order, so this is printed twice. That is over here and over here. Okay, and then 592 will come and it will exchanges will happen. Exchanges will happen in this code. So for example, if you want to understand this, then at this moment, for example, over here, n will be 4, right? So since n is 4, y will be a3 and j will be 2. So y will be a3, that is 592, and j will be 2. So we compare j greater than 0. So j is greater than 0, aj greater than y. So a2 is 705. So it is greater than y, so it will enter the loop. Now in this case, it will put j plus 1 at jth location. That is, it will exchange those. 705 will overwrite 592. Now then j minus minus will happen, and it will find that it is in proper place. So eventually the loop will end because this condition will no longer be satisfied because both of these are 792. Now what will happen is eventually over here, aj plus 1, that is here it is 2, so a3 would be y, that is 705 will be replaced here. So that's how the recursive insertion sort works, and it's a very simple algorithm but not very useful because it's of its runtime. By the way, let me find the book. I should have opened it beforehand. It will tell us. And we should have done. Okay, yeah, this book we are looking for. And we are looking for volume 3 actually. It should be one of these. No, this could be this. So I'll show you the exact complexity algorithm of this in the next video for insertion sort, and in the next video we will study selection sort, where I will show you both selection sort and insertion sort complexity algorithms, complexity calculations. So it's a very simple algorithm. It looks a bit unwieldy as compared to bubble sort. Bubble sort is very simple to understand. It is much simpler than insertion sort. But what you have to consider is that you copy the largest index here, and then you go on replacing it towards left hand side. You go on comparing, and eventually you put it at its proper place. That's it. So if you see this flow here, if you see this carefully, when it propagates from left hand side to right hand side, the array becomes sorted. So insertion sort basically considers arrays in two halves. One is the sorted half, another is unsorted half. So for example, in this case, when you start, this part is already sorted. So when it will hit 592, it will take 592 and put it in proper place over here. Now this part is sorted. Now 433 it will take and will put it in proper place over here. So that's how insertion sort works. So I hope you have enjoyed this video, and I'm sorry that I did not give the complexity calculation in this video, but I promise that I'll give the complexity calculation in next video. And don't mind the soft copies. I actually have hard copies of all these books, so I am a legal owner of soft copies. When I have to read a book, I usually download the soft copy first, and if I find that the book is useful, then I buy the hard copy. That's how. In fact, I ended up buying The Art of Computer Programming multiple times because I end up giving books as gifts also. So that's it for this video. If you like the video, then subscribe to the channel and share it so that other developers like yourself or students like yourself can benefit from the program and the video. So I'll see you in the next video. Happy programming. Enjoy.